All right, so the first one you're dealing with a segment, right? It says L is the midpoint of KM and M is the midpoint of LN. Prove that KL is equal to MN. So the first one's given, L is the midpoint of KM and M is the midpoint of LN. They put them both in together. Second step says KL equals LM and KLM, equals MN. What's that?
Transitive.
Nope. Definition of midpoint. Again, think like, if I didn't know what the word midpoint meant, would I have been able to jump to that conclusion? And no, right? If nobody knew if the word midpoint meant, you wouldn't know that those were equal. It's because you know that you're able to determine that. So the definition of the midpoint. God bless you. The third thing in the line says KL is equal to MN. How do I know that? Yes, I heard it. So did you say transitive? Transitive is a property, right? So we don't need definition. It's just a property itself. But it says that if KL is equal to LM and LM gets repeated, LM is equal to MN, then I can join these two together. That's transitive. And then if I'm using, go ahead.
Can you explain the definition of the midpoint one?
So the midpoint basically says, like by a definition of a midpoint, we know that if a point is the middle, right, of the segment, that it cuts that segment into two congruent parts. So if L is the midpoint of KM, then I know that KL is congruent to LM. Does that make sense? And then the same true for the other way around. If M is the midpoint of LN, then I know that LM is congruent to MN. Okay, so then that last statement with one thing that can help us with it is what we're trying to prove. We already know that. That should be the last thing. The other thing is the definition of congruence, which, what does that definition do? What is the definition of congruence?
Makes it equal.
Good. So if they're equal, so I say they're congruent, or they're congruent, so I say they're equal. Both of those get the definition of congruence, which means that last step should be KL equals MN. Questions on that one? Yep.
I have one on the midpoint still, but I don't understand how do you tell?
How do I know that like KL is equal to LM? Well, you got to know what the definition of a midpoint is, right? So if I know it's like, even if without a proof, right? Even if I didn't give you a proof and I just told you that L was the midpoint of KM, right? So if I said this is the midpoint of this segment, what do you know about that segment?
That L's the midpoint?
And what's that mean? What is a midpoint?
In the middle.
It's in the middle, right? So what does it do to that whole segment?
Makes it equal.
Makes it into two equal parts, right? Which tells you that this one is equal to this one. Does that make sense? So if I say that KL equals LM, the reason I know that is the definition of a midpoint. Without the word midpoint there, you don't know that. Mm-hmm. All right, and then this one is dealing with an angle. So it says ABC is a right angle. X is in the interior of ABC, and the measure of XBC is 45. So there's no picture. My advice is draw one and see what it would look like. So if it's a right angle, I know, not perfectly straight, but I would know it should appear to be 90 degrees, right? So I could say that this is A, this is B, and this is C, or vice versa. All right, so I've got my right angle and I've got it labeled. The next thing it says X is in the interior. What's interior mean? Inside. Somewhere in there is my X. So let's just say again.
Isn't it the bisector?
Doesn't have to be the bisector. So really X could be over here. X could be over here. It could be anywhere within that. The last part of this is what would tell me where it would go, which it says the measure of XBC is 45. So I probably would put it somewhere in the middle, right? Because 45 is half of 50. So I know that this is 45. And I know that this is a right angle. You with me so far? Yeah, so if there's not a picture, try to draw it. It's so much easier if there's a picture, right?
You confused me. You said 45 is half of 50.
A half of 90. Sorry, did I say 50? No, 90. I'm just making sure you're paying attention. All right, so then it says that you're trying to prove that BX bisects angle ABC, and there's a lot of steps here to prove it, okay? First one is given, ABC is a right angle. Second says ABC is 90 degrees. What would that be?
Definition of complementary.
Oh, so close.
Right angle.
Definition of a right angle. Nowhere in there was the word complementary, right? That's okay.
Can you stop?
Third, x is in the interior, that's given. And then fourth says the measure of angle ABX plus the measure of angle XBC equals the measure of angle ABC. What is that?
Addition postulate.
What'd you say?
Addition postulate.
You're missing one word.
Definition.
Addition postulate, but there's two addition postulates, right? How do you know which one you're talking about?
Segment addition postulate.
Almost. So is that a segment? What is it? Angle. So it's angle addition postulate.
How do you know it's angle addition postulate?
Because I said that the whole angle is the sum of the two smaller parts.
Where's postulate?
Say again?
What is postulate?
Postulate's just like a rule. It's a rule or definition. So there's postulate and there's theorem, right? Theorem is something that they had to have first information, and then they sat, somebody in their free time that really, really loves geometry, spent their days proving a theorem, right? Where a postulate is something that's a little bit usually more simpler, that's based on a definition. So it's like a step in between a definition and a theorem, that's all. 5 says given, so angle XBC equals 45, that's given. And then 6 says the measure of angle ABX plus 45 equals 90.
Substitution.
Substitution, we took XBC and replaced it with 45. And then the rest of it is given. You went to 7, which took 45 away from both sides. That's subtraction. You went to 8, which took ABX equals 45, took the 45 and replaced it with XBC, because up here we said 45 equals XBC. And then we went definition of congruence to say that those two were congruent. And then BX bisects angle ABC is the definition of an angle bisector.
How many of these are going to be in the test?
I just glanced at it, but there's a few. Proofs, you mean?
Yeah.
I'll look at it again, but there's like front and back, so it could be 4. I'll look at it again. Yep. Go ahead. I'm sorry, at the front. All right. So B is the midpoint of AC. I'll tell you right now, the word midpoint tells you you're going to do what somewhere along the lines. Why would they tell you it's a midpoint? What is a midpoint?
The middle of the line.
So what would I normally do if I had a midpoint on a line? At some point, you're going to do what?
Cut it in half.
Cut it in half or set the two parts equal to each other, right? Otherwise, why would they give you midpoint? So 1 says B is the midpoint of AC. And the reason there would be?
That's given.
Given. People, if you don't get the given right, I don't know where to help you. Okay? So the given. Then 2 says definition of a midpoint. So what is the definition of a midpoint?
B.
Keep going.
Equals to BC.
Good. AB equals BC. If I'm given the midpoint, I know that that cuts that segment into 2 congruent parts.
You have to put that line on top of it.
Because you're not doing congruence and equals, I'm okay with you just leaving it like that. If you're going from one step to the other, you want to make sure that you put that one, yeah.
How would you know? How would you know to put the little equal?
It doesn't matter. In my opinion, there, because you're not going from that to congruence and congruence to equals, you don't need it. But if there was step 3, was AB is congruent to BC, then I would know I had to put it equals first and then use the definition of congruence to switch it. All right, so 3, how did you get to 3? Substitution. Does everybody see that? Ooh.
Wait, so every time you put a number in,
A number or a variable in the place of something else, that's substitution. Yep. All right, 4. What happened between 3 and 4?
Subtraction.
Good. You subtracted the x from both sides, right? Subtraction property of equality. Feel free
if you didn't
to
write
abbreviate.
property of equality, you'd
I actually don't know the answer to that. I'll find out what Mr. Samariba does. Okay? So the question was, if you don't put property of equality, do you get points taken off? We'll be consistent with whatever he does. Okay? All right, so then 5, addition property of equality. What do we think happened?
You add 2 to both sides.
Not the 2,
Six.
the 6, which makes it
8 equals 2x.
good.
As
Now division property, what probably happened? Good.
Equals 4x.
X equals 4. You divided both sides by 2. 7 says BC equals 3x minus 6. That was given to you. And then 8, BC equals 3 times 4 minus 6. What happened there? Substitution. You took the 4 and put it in the place of the x, right? And then last step.
given.
It's not given. That's what we want to get to, right? So it's actually a combination of both, right? You multiplied and subtracted, right? So I think your book says simplify, right? I'm going to double check on it, but I think your book calls this simplify. Because it's kind of 2 steps in one. It's not really the addition property because you're not adding the same thing to both sides. You're just literally simplifying that side. Questions on any of that? How many of you think you got it right on the quiz?
Oh, on the quiz?
I didn't know how to do this on the quiz.
Okay.
I don't think I did that.
All right, so this time you got given triangles with angles in them, right? So we're not dealing with segments, we're dealing with angles. It says given that angle A is congruent to angle ABC. So this, I can mark that so we can see it. This is congruent to this. That's the only given. So if number 1 says given, then I know that that's going there. Angle A is congruent to angle ABC. Jeez Louise. Number 2 says vertical angles are congruent. What are vertical angles? ABC and DBE are vertical angles, right? And what do we know about vertical angles? They make like a little X, right? What's true about the measure of those angles? They're congruent, right? Which is what that says. That says that they're congruent. So now we're talking this angle and this angle, which would be angle ABC is congruent to angle DBE. Then it says angle A is congruent to angle ABC. Oh, this was, sorry, I wrote the actual problem out wrong. This should be equal. Yep, this should be an equal sign. So what changed from the given to this statement? Almost. The original statement says angle A is congruent to angle ABC, and this one, after I corrected it because it was wrong, says angle A is equal to angle ABC. What is that?
Congruence.
Yep, definition of congruence. So we've switched. We've switched our equals for a congruence or congruence for an equals. Now it happens again in 4. Where else do we have a congruent symbol that we could swap out for an equals?
Angle ABC is congruent to angle DBE.
Good. So the other congruence that we haven't already changed out is here. ABC is congruent to DBE, which means the measure of, oh, let me do it in regular. The measure of angle ABC is equal to the measure of angle DBE. So we went from congruent to equals. Either way, if you go congruent to equals or equals to congruence, it is the definition of congruence. Okay, so then 5. Now this is the first time we've had expressions introduced. So 7x plus 3, which came from here, and 6x plus 15. Good. Substitution. Because we took an actual angle, name, and replaced it with its value, right? From here we said ABC, which is this angle here, is equal to DBE, which is, we set it up on the top, to equal to angle A, right? And if they're equal by name, we can take their expressions and put them in, and that's substitution. Okay, then 6 says subtraction of equality. What do we think happened there? What would have been subtracted?
The 3.
The 6.
You can actually have two answers there, right? I could either subtract the 6x or subtract the 3. Either works.
You should do 6x first.
I should do?
Yes.
Yeah? Okay, so x
It's x
plus 3 would equal 15.
and it's x.
Or, yeah, you can do both because they both have the same reason. Or I could do 7x equals 6x plus 12. And then the next step would have been subtraction as well, right? So it kind of put them both together.
X equals 12.
And here it would have been x equals 12. Or here it would have been x equals 12.
Why does it say F equal 18G?
Because it's a typo. I wrote it wrong. I did this so fast. I'm surprised that there weren't more mistakes. It should be 12. Sorry, guys. So then that last step, this is my proven, right? And my reason there would have been the same. Subtraction property of equality.
Wait, what's the last step?
The last step is x equals 12 and it's subtraction property of equality. But step 6 could have either been this one or this one depending on which order you subtracted. So you could either subtract the 6x first, and then that line would have been x plus 3 equals 15. The next line is still x equals 12.
So x equals 12 is 7, and then
Yep.
one of those would be...
Either one of the ones that are highlighted there could have been 6. You're welcome. All right, so we said number 2, definition of supplementary is that the two angles would add up together to give you 180. So angle 1 plus angle 2 would equal 180, and angle 3 plus angle 4 would equal 180. So step 3 says the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. What happened there? Congruence would be if it said it was equal, so then you said it was congruent, or the vice versa. Almost. So what happened to it within step 2 and step 3?
Oh,
You substituted in, so you literally replaced. Okay, so transitive and substitutions sometimes get confused. And transitive works on like a single object. So if I said that angle 1 was equal to angle 2 and angle 2 was equal to angle 3, so 1 is equal to 3, that's transitive. Okay? But if you replace a value with something, like a number, like 180 gets replaced with angles or vice versa, then that's substitution. So that's what this is, substitution. All right, then 4 is given, right? It says angle 2 is equal to angle 3. So that one's marked. These little red congruency marks are showing you that this would be congruent to angle 2 would be congruent to angle 3. Then 5 says measure of angle 2 equals measure of angle 3. So that's definition of congruence because you literally replace the congruent symbol with an equal symbol. So if two things are congruent, then they are equal, and if they are equal, they are congruent. And then 6 is the subtraction property, and it even hints to steps 3 and 5. So what happened between step 3 and step 5? Or sorry, what happens if I combine step 3 and step 5? And you subtracted something. I'm sorry, I don't know your name, so go ahead.
Angle 1 and angle 4.
Good. So if you're subtracting something, the only thing you can subtract is something you've already said are congruent. So we said that 2 and 3 are congruent, which means I can subtract 2 from this side and 3 from this side, which would leave you with the measure of angle 1 equal to the measure of angle 4. God bless you. God bless you. And then we're going from equals to congruence, which is what? We said if two things are equal, they are congruent, and if they are congruent, then they are equal. What is that? That's the definition of congruence, right? So if you see congruent symbols replaced with equals or equals replaced with congruence, that's the definition of congruence.
I have a question.
Mm-hmm.
But on the top for proof, it says that. It says the same thing on the bottom.
No, that's what you're trying to prove.
Oh.
So this is your given, right? This top part is your given. These are your given information. And then that's your proof. So that's how you know you're done when you get to that step. You're welcome. All right, this is 8. So 8 says, oh, and that's an A in the corner. I erased it. This is an A. Okay, it says that given BAC is a right angle and angle 2 equals angle 3, prove that angle 1 and angle 3 are complementary. So we start with the given BAC is a right angle. What's it mean for it to be a right angle?
Has to add up to 90 degrees.
Not complementary. So if I replace complementary with 90, then that's the definition of complementary. But what have I replaced with 90?
Right angle.
Right angle. So what is a right angle? Something that's 90 degrees. If you did not know what a right angle was, could you have said that that's equal to 90 degrees? No. So what's that mean? What would that be in words?
The definition.
Good. Definition of a right angle. Yep.
Can I do like substituting?
So you're basically substituting with something that is a definition. And that you would just use your definition. If you take a value, so if I said that BAC was equal to 90 and another angle was equal to 90, so then I would say those two are congruent. We're replacing the 90 with something that's equal. That's substitution. But if you're replacing something with its definition, then you want to use the definition. All right, so then 3 says the angle addition postulate. What is the angle addition postulate? Like pretend like these letters aren't even here. What's the concept behind angle addition postulate? Can anybody tell me?
That an example would be like AB plus BC equals AC.
Okay, so if I took an angle and I broke it into two smaller angles, right? And I add those two smaller angles back to get the whole. That's what angle addition postulate is, right? Which is similar to your segment addition postulate, except that's about segments. So in this case, if I was to use the angle addition postulate, which of the two angles in the top right corner, which of these is something I could use the angle addition postulate on?
BAC.
Good. BAC is the only one that's broken down into two angles, right? What two angles is BAC broken down into? Angle 1 and angle 2. So I can say that angle BAC equals angle 1 plus angle 2. Or you could have used the letters. I could have said angle BAC is equal to angle BA, but there would have had to have been another letter at the end of that arrow. Yep.
Would it be wrong if we just put angle BAC?
Yeah, so the angle addition postulate says that one thing is the sum of two smaller parts. So you've got to have both parts of it. Okay, so then 4 says the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So what it did was blend together this step and this step, right? If they both equal BAC, then I can assume that 90 equals angle 1 plus angle 2. And that's substitution. We took something and replaced it with a value, or took a value and replaced it with something. Number 5 is given. It says that angle 2 is equal to angle 3. So we said over here on the right-hand side, angle 2 is equal to angle 3. Those two are now congruent. That was given to us. 6 says definition of congruent angles. So what's the definition of congruence tell you? What does the same mean in math? Good. So remember, congruence is equals and equals is congruence. When I switch back and forth between that, that's the definition of congruent angles. So all I need to write here is that angle 2 equals angle 3. Or the measure of angle 2 equals the measure of angle 3.
Does it matter which one you put?
I won't mark you off on the M. And honestly, as you move further into depth on proofs, you often don't even use that step. Like equals is congruent, congruence is equals. It's when you're kind of learning into it that's important. And then 7 says that the measure of angle 1 plus the measure of angle 3 equals 90. How did I get there? Almost. What did we do? You substituted one angle in for the other. Okay? So that's substitution. I took this statement here that said the measure of angle 1 plus the measure of angle 2 equals 90. And then I took this statement here that said 2 equals 3. And instead of the 2, I plugged in the 3, which is substitution. And then number 8, which is labeled E, is the last step. What's always that last step?
The prove.
What you're trying to prove. What am I trying to prove?
That angle 1 and angle 3 are complementary.
Good. And this is true because we already said that 1 and 3 equal 90 degrees. And if they equal 90 degrees, they're complementary, which is the definition of complementary angles, which is what's there on the right-hand side. The last thing that's for 2-6, so all the stuff we've covered so far was 2-6. This is, I just did the practice and then the answers on there. The second page is the answers for 2-6. I would obviously highly recommend you go over that. And then 3-1 is a lot of definitions. So 3-1 is parallel and skew and perpendicular. And then all those special angles. Alternate interior, alternate exterior, same side interior, or what am I missing? Corresponding, thank you. All of its vocab being able to identify. I would say the biggest mistakes made there are the difference between parallel and skew. What's the difference between parallel and skew?
Skew goes like one way and like another way, right?
Yep.
Parallel, they both go that or like that.
So, but what's the difference between skew and perpendicular? Because one goes one way and one goes the other way.
Perpendicular makes a right angle.
They actually intersect, right?
Yeah.
And skew wouldn't. So if you think about like the lines in the floor, right? Like if you look down at the tiles, if the lines that run from the front of the room to the back of the room would be what kind of lines? Parallel. The lines that run front to the room and the back of the room and then side and side would be? Nope. They lie in the same plane. Perpendicular. Line running like front of the room to the back of the room in the floor, and then in the ceiling going left and right. Skew. Because they don't touch and they don't intersect. I mean, they're on the same plane. Does that make sense? Okay. All right, I think you guys are going to be okay.
Thank you.